demo shows our approach from the capacitive detection and the variations in this, minute variations in the capacitance to a digital converter. So what happens in a situation like this, if a human finger or anything that's human related, even if it's a finger put in glove, it will detect the variations in the capacitance and will translate into a certain amount of bits, and certain level variations will show the difference between the original capacitance and what the capacitance it is now. We would like for visitors to understand how effective our solution is versus the competition, because we are very inexpensive, it's our very simple design. We sense a very minute variations in capacitance, it's in femtofarads. So we can actually create not just a touch switch from this, but also proximity detection on 10 centimeters, as high as 10 centimeters away. So that works quite well in the hazardous environments, for example, or the hospitals, things like that. The main difference between us and the competition is the competition is a lot more complex. They require a microprocessor inside. Ours is essentially based on logic alone. So it's less complicated, it's less expensive, and the most important part, it's also very, very cheap, right? The important for the visitor is that our demo doesn't have to just do the touch switch when you're touching the board or, let's say, refrigerator application, for example, or some hazardous environment, but it shows that you can do a proximity detection. So you can be up to 10 centimeters away, in some cases even 30 centimeters away, and you will detect presence of variations in capacitance, and you can turn on or you can turn off a certain switch that the customer would be working with. The list of applications is endless. It starts anywhere, let's say in hospital applications or industrial applications where you cannot possibly have buttons that can be, the rain can be poured on them, oil, dust, you name it. And the main issue also in industrial application is our device cannot possibly pick up noise. It actually isolates noise of any kind. So there's no need for a special construction, any extra cost related to it. And this is one of the industrial applications. The second good application is in the white goods, where you will see, let's say, new refrigerators coming out with buttons and displays. So this is another application for our device. You can use up to, let's say, 16 or 256, or in the matrix application, 1024 and up. And of course, it's touchless in some cases, or a very easy and a very nice, easy touch on that. The feature is, because the part is very simple, so there's no need to program it. There's only one external component that requires change if you would like to vary the sensitivity to go from, let's say, 10 centimeters to 2 centimeters touch, or no proximity detection at all. That one part. Second, probably one of the best effects, is we do differential sensing. And with that, any noise that can appear on the line will be canceled completely right at the part. So you can run long 1 meter, 2 meter, 3 meter wires, and it will pick up noise, but it will be canceled at the very end. So that makes a layout and design very quick, very simple. And the testing of it will be in less than 2 seconds away from the manufacturing process.